Okay, let's have a look here. So we'll just change this expression into a quarter x power a half plus x power minus 1. So the first derivative would be bring down the power, reduce the power by 1, bring down the power, reduce the power by 1, and just clean that up a little bit. That would be 1 over 8 root x minus 1 over x squared. When is that positive? That is, when is 1 over 8 root x more than 1 over x squared? That is when 8 root x is smaller than x squared. So that's when 8 is more than x power 1.5, 3 over 2. So that means if you power 2 over 3 both sides, that means when x is more than 4, it's increasing. And then when x is less than 4, that's decreasing. And that kind of makes sense because when you look at the shape of the graph, it's coming down from infinity. It's coming down to 4. And then I guess when this vanishes away, it kind of returns back to a sort of a square root shape. So that's for A. So B is the local min or max. So when x equals 4, we have a min. Has to be a min. We could calculate the second derivative to find out, but let's calculate the second derivative now from here. So bring down the power, 1 minus 1 over 16 x power, reduce the power by 1. And then plus 2 x power minus 3. Now, concave up. So we want the concave up. So concave up is the second derivative is positive. So that's 2x power minus 1 over 16 x power minus 3 over 2 should be positive, which means that should be more than that, which means 32 over x cubed should be more than 1 over x square root of x cubed. So maybe we know that x is positive, so we can cross multiply. 32 root x cubed needs to be more than x cubed. So you could divide by this, and that would make a root appear here. And then you could square both sides. So 32 squared, x cubed has to be smaller than that. So cube root of that. Cube root of 32 is 4. Squared is 16. So when x is less than 16, it's concave up. And then when x is more than 16, concave down. So that switch happens at 16, where we go from concave up to concave down, and the inflection point is at x is 16. But it's not marked as a T question, so I guess not to draw it. Let's check the answer since we do have this answer. 239. 239. 239. 239. Nice. Increasing. Oh, I forgot. That's hilarious because in the previous questions, I've been very careful with the bounds and then forgot to mention in this one exactly when they do mention it. That's hilarious. Minimum at 4. Concave up. Less than 16. Oh, no. Oh, is the cube root of 32 not 4? Oh, no, it's not. Okay, so, yeah, okay, so it's the cube root of 32 squared. The cube root of 32 squared. Okay. Yeah. Oh, which they can simplifies. Yeah. Let's see. 32 squared. And then yeah, it's correct. It's correct. Same 8 cube root 2. Same number. Okay. Concave down. Yeah. Inflection point. Why did I say 16 actually? What's wrong with me? It's not. It's this number. What's wrong with me? 8 cube root 2. Still suffering from COVID effects. Okay, let's get this one flawlessly now. First derivative is the bottom squared, the bottom times the derivative of the top, minus the top times the derivative of the bottom. So when will this be positive? That is when ex is more than ex. So that means it's increasing when x is more than 1, decreasing when x is less than 1, and I should also say when x can't be 0 when it's less than 1. Okay. B is stationary point. So that is when x is 1 and it's a minimum. C, concave up. So second derivative. So that's the bottom squared, the bottom times the derivative of the top, which is ex, product rule, plus ex minus ex. They cancel. And then x squared times x is x cubed. So actually it goes back to ex over x. That's interesting. That's interesting. No, I'm not finished. See, the bottom times the derivative of the top. I forgot the last part. Minus the top times the derivative of the bottom, which is 2x. So yes, they still do cancel. And there's an x squared and an x squared. So x squared. So that becomes a square. Oh, no. What? That x fell outside. I need to be more careful. The bottom times the top minus the top times the derivative of the bottom. Okay, now that x is gone, and that square is gone, and that's a cubed. And that cancels with that. So that'll be x times x, x squared ex minus 2 xex plus ex all over x. So that will be ex over x times x squared minus 2x plus 1, which will be x minus 1 squared, which becomes not important, except for at the inflection point, actually. So the inflection is at x equals 1, but concave up is when this is positive. So that would mean just when x is positive. And then concave down is when this is negative. So that means when x is less than 0, an inflection at 1. And I want to draw this. Have a look at it, since I can't check the answer. If I can. If it loads. Okay. Now, let's see. Okay. Concave down and concave up. That definitely checks out. Concave up to the right. Yeah, that's definitely right. Inflection at 1, though? No, because the first derivative at 1 can't be 0, and it is. So we don't know what's at 1. Should have checked that. I didn't realize they were going to be sneaky like that for these questions. Yeah, they got me. Increasing greater than 1, decreasing less than 1. Yeah, minimum at 1. Yeah. But inflection. Also I made a mistake. It's plus 2, and I said plus 1. I lost that 2, didn't I? Good thing I'm checking. X squared minus 2x plus 2. So that quadratic doesn't have solutions. So none. Okay, so it wasn't that they were being sneaky, it was that I made a mistake. I guess that's better. Okay.